there may be some water that has yet to be driven off. Are you defining cutoffs for different fluids, or are you defining specific cutoffs for each case? If you want to do this, how would you do it? Okay, well, so the way it kind of fell out on that T2 distribution is the bitumen and the clay-bound water are beneath 3. So it just happened to be that way. If you had to put a T2 cutoff down there less than 3 milliseconds, you may be able to get away with it depending on the properties of the bitumen, but it's good enough to put a 3 millisecond cutoff to get rid of the bitumen and the clay-bound water. As far as the one that's, and then, you know, based on the work we've done, you know, with these injection tests and T1, T2 ratio, we're not really seeing a whole lot of water between 3 and 10 milliseconds. Where the problem is above 10 milliseconds, and that's where it's mixing with this great movable oil signal. And separating those out, and I don't think you're going to have a unique T2 cutoff. The signals overlap. Now the question about whether it's actually producible water up there or not, man, that's a good question, and I'm wondering the same thing, right? I mean, how much water is actually coming out of that intergranular pore that's above 10 milliseconds? And I don't have the answer to be able to generate a T2 cutoff, because, and I don't know, get water in there and, you know, separate out the two fluids to get individual T2 cutoffs. So not sure how to answer that, but it's certainly something we'd like to do. Can you estimate NMR permeability from T2 distributions like it's done for conventional reservoirs? I would say yes, and the reason why I say that is because the correlation, you can pull off a correlation of pore throat diameter from the mercury injection to the pore size. So the NMR is measuring pore size, and then the mercury injection stuff, it correlates with the pore size distribution. Now in terms of what the absolute permeability is, you know, there's a host of different permeabilities coming out of different labs, depending on when, particularly for liquids, and it has to do with, you know, the drying procedures, when they're injecting the gas, what mesh size it's crushed up to. But as far as the pore size being correlative with pore throat, which drives the permeability, I'd say yeah, that it should work. And this last one's about cased hole. This is in language I can't read here, so, but I was told it was about cased hole logs, so I'll just kind of wing it. Cased hole, yeah, I would say you're a little bit desperate when you start going to cased hole, but it's certainly something we've done. You know, you're not going to get to the level of detail that you would in an open hole analysis with, you know, NMR breaking things out. And it also, on a cased hole analysis, it depends how much empiricism that you already have. So if you've got a whole lot of empiricism already built up, you can get a spectroscopy log, you can get a density log, and you can put out the same type of analysis that you would before. But the issue is if you're going to try to do that in a brand new area, that's a whole different ballgame, because you don't have the empiricism built up to interpret that cased hole log. That's it.
Thank you very much. Thank you.